Okay, so we're back. We're going to look at a couple more examples here. All right. The example here we're looking at is what is given the sine is 3/5. Find the secant of the double angle. All right, so we immediately go to triangle. Here's our angle X. Here's our opposite 5. So 4 is our adjacent side. So then the cosine of angle X is going to equal 4/5. And of course, what do we need? We need the secant of 2x. So we'll say the secant of 2x is going to, of course, equal 1 over the cosine of 2x, which is going to equal what? 1 over the cosine squared of theta minus the sine squared of theta. So we're just going to put those values in. The cosine squared is 4/5. That's going to be squared minus the sine squared, which is 3/5. It's going to be squared. So it's what? 1 over 16/25 minus 9/25. So I guess that's 7/25, and reciprocated is 25/7. So there you have. That's all you have to do with that. This is going to just be expanded again. Sine of theta cosine of pi over 4 plus cosine of theta sine of pi over 4. And then you're going to have to expand this one out in a similar fashion and connect your terms together, okay? This is a little bit of a job here, okay? Let's remember, here we got a half angle identity for cosine. Cosine half angle identity, let's put it down. Cosine of theta over 2 is equal to the root of 1 plus the cosine of theta over 2. Now basically all we can say is whatever this angle is, the angle here is double. So I'm just going to put it as cosine P is equal to the plus or minus the root of 1 plus the cosine of 2p over 2. Now if I square both sides, I get an expression for the cosine squared of p. Cosine squared of p is, of course, when this is squared, we don't have to worry about the plus or minus. We just get 1 plus the cosine of 2p over 2. So in other words, this gives me a way of expressing the powers of the cosine in terms of multiple angles rather than in terms of power. So, but the one I'm asking for is what is the cosine, the fourth power of the cosine. So then the cosine of the fourth of the power of x is simply the cosine squared of x squared, which is simply going to be this expression squared. So it's going to be 1 plus cosine of 2p squared, which of course when squared is going to be what? 1 plus 2 cosine of 2p plus cosine squared of 2p all over 4. But now I still have a power of the cosine which I want to resolve. So I'm going to use this again. So basically, again, if my angle here is going to be 2p, then this expression over here is going to involve a 4p. So I'm just going to break this up as two fractions. So that's going to be 1/4 of 1 plus 2 cosine of 2p plus 1/4 of, now doing this substitution in here, okay, will be 1 plus the cosine of 4p over 2, okay? And then so that one expanded will be plus 1/8 of 1 plus the cosine of 4p or 4x, whatever expression you want to use, doesn't really matter. Okay, and then over here, if I want to bring that with an eighth, then I'll double up everything, so that'll be 1/8 of what? 2 plus 4 to cosine of 2p. And I think we're there. We can put everything together. We can express it in that, like that expression that we were asked to. This is an equation, an equation, an equation. Okay? So you got to use the double angle. Sine, what? 2 sine cosine. 2 sine of theta cosine of theta is equal to the cosine of theta, and solve. Just don't divide by the cosine and lose the solution. You know better than that. Okay, this is going to be very similar to that type of expression, but of course we need the sine for the angle, and that comes from the other half angle, which we went over in class, so I think you should be able to do that. Well, let's just remind you of that. Okay, so the sine, the half angle sine of theta over 2 is plus or minus the root of 1 minus the cosine of the angle over 2. So then, again, the ratio here is 1 to 2. So if this is now expressed as theta, then this is going to be expressed as 2 theta. And if I square it at the same time, I can lose my radical, and then I get this 1 minus the cosine of theta over 2 as an expression for the sine squared, which you again will just replace it here, replace that previous expression up there. And we're going to terminate it with this and pick up a couple of the others in another video.